Hello and welcome to Chapter 6, Section 4, Solving Special Systems. Now, what we've had so far are called consistent systems because our system of equations have all had at least one solution. When two lines do not intersect, they are parallel, and there is no ordered pair that will solve both equations. That means there's no solution, and this is called an inconsistent system. So what this part of this section is going to do is show you lines that have no solution, and they're going to ask you to prove that mathematically. And essentially what you're doing is you're proving that they have the same slope. So we have y equals x minus 1 and negative x plus y equals 2. And you have to prove that there is no solution. So we're going to put this in the y equals mx plus b format. We're going to add x to both sides, and we're going to end up with y equals x plus 2. And we're going to see that this has a slope of 1 and this has a slope of 1. And because they have the same slope, they are parallel. But because they intersect the y-axis in a different point, they're not the same line. They are parallel. They run next to each other. So there is no solution. And anything that you put in here so that you solve for x will not also be a solution for this equation. Another way to solve this is to actually solve for x. So we're going to treat this like it's a system of equations. So here we have y equals x minus 1 and y equals x plus 2. What if you don't notice that the slopes are the same? Well, so let's take this and this, since they both equal y, and set them equal to each other. So x minus 1 equals x plus 2. And we're going to subtract x from both sides, and the answer we get is negative 1 equals 2. And that's not true. When we try and find something that some point that is found in both lines where these two lines intersect, we get a no solution answer. The third way to try and solve this is to graph both lines. And if you have graph paper, this is very easy, but we're going to start at negative 1 and we're going to go up 1 over 1, up 1 over 1. We're going to end up with this line here. And then here we're going to start at positive 2, and we're going to go up 1 over 1, up 1 over 1, and we're going to end up with that. And we'll notice that these two lines are parallel, which means they never cross. There is no point that is found in both of these lines. So pause here and check it out number 1 on page 420, and come back when you've finished. So for number 1, this equation, y equals negative 2x plus 5, and we've fixed this equation to be in slope-intercept form so that y equals negative 2x plus 1. So we can see that it has the same slope, which means they are parallel lines, and but they are different lines because they start at different points in the y-axis. And if we solve the long way, the mathematical way, so that we can prove it, then we say 2x plus y, which is negative 2x plus 5, equals 1. And when we solve this, it is not true. So there is no point that solves for both of these. If two linear equations have the same graph, then they are the same line, and they will have all of their ordered pairs in common. And sometimes you will end up with that. And the question for these are, show that these two lines have infinite solutions. So one way to do it is to prove that they are the same line by putting them both in slope-intercept form. This is already y equals mx plus b, so we're going to change this. We're going to subtract 2x from both sides. We're going to subtract 1 from both sides. We're going to end up with negative y equals negative 2x minus 1, and then we're going to multiply the whole thing by negative 1, and we end up with y equals 2x plus 1, and look, they're the same lines. So any x and y that you have that will solve for this equation will also solve for this equation because they're the same thing. You can show this by graphing. You can also show this by finding a point. You can also stick this in for y. So 2x minus y, 2x plus 1 equals 0. So if I distribute this negative sign, 2x minus 1 plus 1 equals 0. And sure enough, these two cancel out and these two cancel out, and I have 0 equals 0, which means there are infinite solutions for these two equations. So pause here and try one of these for yourself so you know what it feels like when you get something like this. Check it out number 2 on 421. Come back when you're done. Check it out number 2. The first thing I tried is to make them both into y equals mx plus b. And here I have y equals x minus 3, so it shows here that they are the same line. I also substituted this in for this y, so x minus 3 minus 3 equals 0. And when I distribute that negative x, I get x minus x plus 3 minus 3, so these two cancel out and these two cancel out, and I end up with 0 equals 0. There's no x in here. When I solve for y, it totally takes both y and x out of the equation, which means there are infinite solutions, which means these two are the same line. So an inconsistent system is when two lines are parallel and they have no points in common. The consistent system, there are two types. The first one that we did sections 1 through 3 about are called independent systems, where there's exactly one solution. These are when two different lines intersect at one point, and when you solve the system of equations, you find that one point where they cross. And then we have a dependent system. This is when you have infinite solutions, and this is when mathematically they end up being the same line. So the next thing it's going to ask you to do is classify each system and give the number of solutions. So it's either going to be an inconsistent system with no solutions, an independent system with one solution, or a dependent system with infinite solutions. And it's going to give you a bunch of pairs of lines, and your job is to get them both into positions where you can solve them to some extent. And I'll solve two ways so that you can follow your favorite way. My favorite way to start out with is to make them both be in slope-intercept form. So I'm going to divide everything by 2 here. So y equals 1/2 x plus 1. And I'm going to add 1/2 x to both sides. And y equals 1/2 x plus 1. These are the same lines, so there are infinite solutions, and it is a dependent system because there are infinite solutions. This one, same story, y equals 2x minus 2 and y equals x plus 1. Well, these don't have the same slope, so I'm going to solve these like I would have solved 6, 1 through 3. So 2x minus 2 equals x plus 1 minus x. Negative 2 equals, nope, x minus 2 equals 1. Plus 2, x equals 3, and when I stick x equals 3 in here, y equals 3 plus 1, so y equals 4, and my solution is 3, 4. That makes this an independent system because there is exactly one solution, because these are intersecting lines. So give this a try. You've got 3, A, B, and C on the top of page 422. See what it's like to encounter each type of pair so that you can give that part a try. Okay, pause here and come back when you're done. So for 3a, we've changed this one to y equals negative 1 half x plus minus 2, and we've changed this one to y equals negative 1 half x minus 4. They have the same slope, but different y-intercepts, which means they are parallel lines, which means there are no solution, which makes this an inconsistent system. With b, I have two different slopes, which makes these different lines. So I've set this half to equal to this half, and I have solved x as negative 1, and when I plug x in as negative 1, I get y equals 4, which gives me 1 point, which means this is an independent system with only one solution. And with c, I have y equals 2/3 x minus 2 and y equals 2/3 x. They have the same slope, but different y-intercepts. There's no solution. This is inconsistent. So what they didn't give you here is a set of the same line. So I'm hoping you'll easily see that when you hit that in homework. Next, we have a business word problem. We have Comics Now and we have Dynamo Comics. And if these sales patterns continue, will the sales ever end up being the same? Will they ever equal each other? Well, we need to find our pattern. To get from here to here, we've added 40. And to get from here to here, we've added 40. And to get from here to here, we've added 40. So we know that for Comics Now, whatever year it is, it's going to be 40 more. So it's 40 times the number of years. This is after 0 years, this is after 1 year, this is after 2 years, this is after 3 years. So it's always adding 40 per year, and they started with 130. Where for Dynamo Comics, they are increasing 40 here and 40 here and 40 here. So they are also increasing 40 each year, but they started with 180. Now, logically, if each of them are increasing at the same slope, at the same rate, but they're starting at a different y-intercept, we know that they are going to continue to run parallel lines. And so no, there is no solution to this. They will never meet. These guys are always going to have sales that are less than these guys by the same amount. Mathematically, these are parallel lines because they have the same slope, and this is an inconsistent system. And the answer to the question, if the pattern continues, will they ever be equal? And please explain. This helps you explain that they will never be equal. Okay, you have a problem just like this on the bottom of page 422. Check it out, number 4. Pause here, try it so that you're strong in your word problems, and come back when you're done. So number 4, Matt starts with $100 in his checking account and he deposits $20 per month. And Ben starts with $80 and he deposits $30 per month. When will they be equal, or will they ever? Well, they're increasing at different rates, so it's possible. They are not parallel lines. So we're going to take this part and set them equal to each other. And we're going to solve for x, and here x equals 2, which means 2 was the number of months that they deposited this much money in their accounts. After 2 months, they will equal. And I'm going to stick 2 in just to check. And for this equation, y is going to equal 100 plus 40 if x is 2. And for this equation, y equals 80 plus 60. And those both equal 140, so that works. After 2 months, they will equal. Your homework starts on page 423. You're going to do numbers 12 to 28 all. And please see the next video if you have any questions about the word problems, and you're always free to ask me when I see you tomorrow. Take care.